Oh, okay, everybody. So, good evening, good evening, good evening, good evening. Now, tonight, we are going to be talking about positive and negative numbers. So, what we're going to be doing is we're going to be looking at the number line. Okay, the number line. Don't know if you can see my hands here. Looking at the difference between the two different types of integers, because that's what they're called. Then we're going to be looking at how to solve problems using those values and mixing them up. Now, I'm just going to erase this here so that we can get started. If something happens along the way that's just not perfect, then that is fine and dandy. I was feeling a little bit superficial, probably a little bit dry, and just don't fake your feelings just because you have to act normal and be appropriate and blend in and try to conform and go through the motions and everything and try to excite people. I mean, if you're not feeling it, then just don't try to do that, because it's uncomfortable and it gets old really quickly. You try doing it, because I can tell you what, your balloon is gonna run out of steam before you know it. That's not what I'm gonna do this year in 2021. Okay, now, so, okay, integers. Actually, it's spelled Integers. So an integer is a number that is either positive or negative. Okay? So a positive number, think of the positive sign first of all as something good. Think of a value of something that is positive. What does that mean? It means that its value is very, very high, very up there. You know, if you're thinking about money, that would be a really high amount of money. So, you know, and also another thing is the cross, if you're thinking about, you know, Jesus Christ. So, what are you doing when you're adding? You're getting bigger. Opposite from the fact of subtracting, which is a minus sign. You take away the little, you know, vertical up and down thingy. Well, minus is the exact opposite. When you're subtracting, you're getting smaller in value. Think of, you know, money really, really low. Think of if you're being very, very poor. Think of a situation that's really, really bad. That is what subtraction is in the general terms of things. So, you do it all the time when you add 6 plus 8 and subtract 7 minus 2, so it's really nothing new. Now, we are going to be looking at the number line. So, for the beginner's perspective, when you think of a number line, you think of the 0 starting right here, and then say you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and so on and so forth. There's also there's also other number lines that go like this. 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. So they're counting by twos. You could do the same for counting by threes. So you can do like 0, 3, 6, 9, 12, 15 if I'm counting right. Well, okay, let's just go on anyway. So 16, 17, 18, 21. And you can do the same for a number line of 4, 5, 6. It's starting here and it's increasing in value as it goes further to the right. So think of if you're going right, it's the right way to go. It's a really, 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 very, very beneficial way to go. Well, it gets bigger as you go further down the line. But that's not what the full official number line is. Now let's come back to what we were talking about with integers. And let's draw the line again. So let's start out here real simple with the el cero. Let's start with the 0. So you see that we have the number line. We have it in the middle here. We see the middle part of it. Okay? So, you have the 0 here. And as I've already said, when you were going further to the right, you were getting bigger in your number values. So we would still fill in the same here. So you're looking to the right. So 1, 2, 3, 4, 5, 6. Or you can do it by 2s, 3s, 4s, whatever you want to do. Then what's going to go on the left? Well, that's where this comes in here. We have this and this, but let's look more specifically at this sign right here. So, as you can see, this is a negative sign here. I'll draw it again. So this is a negative sign. So, a positive number, a positive integer would just be like a regular number, say 8. 8, or my lucky number 6. Let's stick with 6. So instead of putting the plus 6, you don't even need that because 6, it says positive 6, so just 6 because it is indeed a positive number. But that's not the case when it comes to a negative number because you need differentiation where it does have that negative sign. And I won't go into the specific reasons of that because there's really not really anything else to explain. But so you have, say, negative 6 would look something like this. So you can tell the difference. Positive 6, negative 6. Regular 6, negative 6. So that's what would go here, and you see that it's a little sloppy. So then, what do we do here? Well, on the left is the negative numbers. So, as you go further to the left, it gets smaller. It decreases in value. Think of if you are underwater and you're going further down into the water. You're getting deeper into it. Okay, and what is the level of volume that you're at? Think of a thermometer. Think of temperature. As it's getting up, it gets more into the positives, a high of, I don't know, 78. And then as you're getting warmer, you're getting hotter, you're going higher, more positive numbers. Opposite going lower, you're getting colder, and the numbers go down slowly towards 0, and then below 0 would be, say -1 and then -2. So instead of saying, instead of putting, say, so here's how it's going to go. You see that, so for example, the number to the right and to the left of 0 is always 1. So you start at 0, you go 1, 2, 3, 4, 5 this way. You start at 0, and then you just go, 1, 2, 3, 4, 5, 6, 7. But instead of going right, you're just simply going left. But you're decreasing. So, I think that that's really the only way that I can explain it. I think that the visual of it really, really shows. So, -2, -3, -4, and so on and so forth. Okay? So, -1, -2, you realize that it's not -4, -3, -2, -1, as you can see here. Because, you might say 2 is a bigger number than 1, but it's to the left. It's further to the left. If it's further to the left, it's smaller. Further to the right, it's bigger. Let's go. Further to the left, it's smaller. Further to the right, it's bigger. Boom! Further to the left is smaller. Further to the right is bigger. Could make a huge song about that. Okay. Well, that's my little, fun little indicator there. Okay. So, when you have, obviously, +3 is bigger than -3. Oh, they're equal in their number. No, because you have -3 and you have +3. So the +3 would be positive, good. Bigger is better. Kind of American motto. American belief, philosophy, way of looking at doing things and going about things, the kind of thing. -3 is smaller. So, even though 4 is a greater value than 1, if it's negative, then it's less. You're going further this way. So I think that you can understand that. Now, let's put this into solving. So, actually, let's do something else before we decide to do that. So I'm going to erase this, and I'm just going to simply leave this subtraction sign, or this negative sign, like that. Okay, so plots when it comes to a number line. So I think that this is, pretty easy to do. So you have 0. So let's start at 0. Let's just make a little dot at 0. So how many places from +4 to 0? Let's count. 1, 2, 3, 4. And you can do the same with here. I'll just erase these points here. So -2 to 2, positive 3. 1, 2, 1, 2, 3. So it would be 1, 2, 3, 4, 5, I believe. Okay, I completely forgot about something. What about 0? Is that a positive or negative? I could compare it to an atom in science. This is the nucleus, the center of the atom. It houses protons. And then and then orbiting around that would be the electrons. Protons would be positive, electrons would be negative. Then, to take up space, you have the neutrons in the nucleus. Well, if the protons have a positive charge, electrons have a negative charge, what do you think the neutrons have? Neutrons. What does that word mean? Oh, what does it sound like? Oh, neutral. Neutral means they have no charge. So these would be the protons. So this is your little handy-dandy way of thinking about it. And then these right here would be your electrons. This would be your only neutron. So 0 is not a positive nor negative number. It just is just that odd one out. It's like being born on Leap Year's Day, the 29th of February, aliens. 0. Well, that stands on its own. Oh, and by the way, you're not aliens if you're born on the 29th of February. I was just making that up because, well, what a sad life to live if you're... Oh my goodness me, I did not realize this. If you're born on the 29th of February, then that gives you an advantage because you can stay younger for... No. Well, you could stay one age for a longer period of time. Oh my goodness me. Well, there is a change in positive. Okay, never mind what I said. Okay, everybody says things. Okay, once in a blue moon. Now, I'm sure that you have all seen this kind of thing. You have this, you have that, and then you have this, which, as we know, is an equal sign. If you do it in any problem, say 6 plus 5 equals 6 plus 5, and then what do you get out of solving this? So 6, 7, 8, 9, 10, 11 equal 11. You know that is. Okay? But are we really sure about what these things are? Or do we think that we know them, but we don't yet know what they really are? Well, looking at this and looking at this, these are both linked together as one, but they're two and they're separate. So the little hint that I want to get at here is the mouth of an alligator. The mouth of an alligator. Ooh, I'm hungry, says the alligator. The alligator is really, really hungry. It really wants to eat a feast of different aquatic animals. And it sees one collection, say, of animals, and then the other collection. One is smaller, one is bigger. This one is smaller, this one's bigger. well, the alligators, well, especially because the alligators, he is very, very hungry. So, what do you think that he will want to eat? More of it? Well, okay. So, just, okay, well, let's actually say that the pile of food, of animals that is more than the other, the one that has more is fresher and better quality. Fresher and better quality. The alligator is much more a fan of, say, crayfish than shrimp. Crayfish and lobster than the shrimp and the clams over here. And there's more amount of the thing over there. So what do you think that the alligator would want to do? Well, it would want to eat the thing that is more of. Thing that is more, contains more, and it actually tastes better to the alligator. So, this is the mouth of the alligator. See how it looks like a mouth? So, this is the other mouth of the alligator. Oh, Mighty Mac idea. The engine with, one, Mighty Mac. It's kind of like, if you put glued two bodies together, one over there, connected in the same engine. Well, now I want you to look at the next thing that these symbolize, which would be, isn't this familiar? Arrows. You have the mouth of an arrow, right here. This would be the mouth of an arrow. This would be the little line, and the little line is going into this part of it. Okay. So this part, the little corner part in the middle, the line is heading towards that, either over there or over there. So it tells you where the arrows are pointing. Obviously, this arrow would be pointing to further right. This arrow will be pointing further to the left. So, the mouth, the arrow, is going this way, that way. It would go this way if it's this arrow, and then this way if it's that arrow. If you have this, an arrow does not look like that, or an arrow just doesn't look like this. And again, it's visual. So the pictures do the talking for me. Okay? A picture's worth 1,000 words. Really it is, but still. Now, think of the food that the alligator is eating as numbers. So let's say we have, 3 and 6. So here, actually, let's erase this model here. Now that I've explained that, and let's do it over again. Let's do it over again. So, here, actually, let's erase this number line here, because I really don't think that we need this here. So, taking two number values, let's say, we have 3 and 6. Is it less than? Is it greater than? The reason why we say less than is because if the arrow is pointing that way, we're getting less further to the left. Arrow is pointing this way to the right. We're getting bigger. Arrows do not and will not look like that. And the lines are not even the right places. But, well, that's really the point, because it's flawed. It's all wrong. So, draw that again. Less than, greater than. We obviously want to eat the pile of more food. So 6, both of these are positive numbers. So we look further to the right. 6 is obviously a bigger number than 3. So we want to eat more of that. So we want to get to the bigger number. So 6 would be greater than 3. And it makes sense because if you're thinking about, say, 6 on a number line, then you would have to move this way to the left. You're decreasing to get to 3. 1, 2, 3. See how that works? See how these two both tie into each other? Okay. Now we're going to change it up a little bit. Now we're going to change it up, baby. We're going to do a little change. We're going to do a little change. We're going to change it up. Pew! We're going to change it. I don't know. I could be, Laura Theodore's best associate with that. Okay. So, let's say we have, 3 and -6. Are you serious? I did something so wrong because 3 is a bigger number than 6 because it's positive, but it's over there. It's over to the left, and -6 is a negative. It's to the left of the zeros, and it's less than, below 0, less than 3. Switch them up! I'm here to tell you, I don't think that it matters. Okay. So, what is the bigger number? That is what we were asking. What is the bigger number? That is the big thing to be focused on. Well, -6 is below 0. If it's negative, it's less than 3, which is a positive. It's to the right of the 0. Remember, 0 is that neutral. So, anything to the left, negative. Anything to the right, be positive. So, left, right. Right, over here. Okay. Yeah. Okay, right, positive. Left, negative. So 0 would be that marker between them. So, but obviously know the bigger numbers here, and then the smaller numbers over there. So, any number with a negative sign that's to the left of 0, it is a smaller number. Thing to the right of the 0 does not have a negative sign. It's a bigger number, so we'd obviously know. Well, obviously, 3 is a bigger number than -6. It's just blatantly obvious. It's easy to, remember. There's not a whole lot of explanation to that. So, remember, the mouth. Think of a mouth. It's open up into. It doesn't go like this. It doesn't go like this, becoming a blockage to it. It has to have that opening. So, 3 would be a greater number than -6. So 3, oh, baby. See how this works? Let's see how this works. Okay, so you have 3 here. Let's say we have 3 right here. And we go further to the left, we would get -6. Over to the left is further -6. So 3. 1, 2, 3, 4, 5, 6. It doesn't matter. You know, if the bigger numbers here, positive numbers here, negative numbers there, that doesn't matter. And I think that you can see why that does not matter. We could do decimals, but I think that those are pretty easy because all you do is you just bump it up. 5 and above, give it a shove. 4 and below, leave it alone. Let's not worry about that today. So, now, let's get to the solving of the equations with these two things, with the positive and the negative. First and foremost, let's start out with, say, 6 plus 2. Okay, well, 6 plus 2, that's easy. 8. More specifically rooted in what we're doing. We have a positive 6 and a positive 2. The rule is, if the signs are so, okay. So obviously for this, we have a positive and a positive. So when we have two numbers in a problem that are the same sign, we add. 6 plus 2, obviously that would be 8. So let's do another example. So let's just do, say, negative 6 plus negative 3. Well, we have a negative 6 and a negative 3, taking two negatives. We have two negatives, well, we would be decreasing in value, yet getting bigger in the general, but we'd be decreasing because we'd go further down that number line. We have 6 plus 3, we'd go further this way to the number line. So 9, would be bigger than 6 because it's further down, and bigger than 3 because it's further down. And, and negative 9, which is the answer of this one, would be further down, which would be less, and we're adding these because they have the same sign. Negative 6, negative 3, both negative numbers. We add 6, 7, 8, 9, and we just leave the sign for numbers. So obviously, if we have two negatives, obviously we get more negative. A negative equals a negative. Positive equals another positive. I'm talking in math rules here. Okay. However, that changes. We're going to say 5 plus negative